Hello, my name is Haley Morgan, and today I'll be representing my research on the impact of melting polar ice on sea level rise. This presentation is part of my coursework for Geology 33-14, Oceanography and Meteorology with Dr. Kennedy. Today's date is April 20th, 2025. And I'll be walking you through why this issue matters, what's happening globally, and what it means for our future. A little bit of our content overview is going to be climate change is being affected by the melting of polar ice at an alarming rate. This has a big impact on global sea levels, weather conditions, and surrounding coastal ecosystems. This topic ties directly into oceanography and meteorology, and our purpose is going to be to discover how the melting of polar ice impacts the current sea level and coastal environments. A few key terms that I'll be using throughout this presentation will be polar ice, sea level rise, cryosphere, glacier, and thermal expansion. Melting polar ice is one of the most visible and alarming signs of climate change. The ice at the Earth's poles, especially in regions like Greenland and Antarctica, are melting at increasing alarming rates, contributing to global sea level rise. This topic is especially important in the fields of oceanography and meteorology because it affects not only sea levels, but also ocean circulation, weather patterns, and coastal systems. The goal of my presentation is to help you understand the science that goes behind polar ice melting and the data supporting it, and along with all those, the real-world consequences we are starting to see. Before we dive in deep, we're going to do a little bit of background information. To understand the impact of melting polar ice, it's important for us to first define some key terms that may be used throughout. The cryosphere refers to all of the frozen water parts of the Earth system. This could include things like glaciers, sea ice, and even ice sheets. One important process related to sea level rise is thermal expansion, and this could include the increase in the length, area, or volume of a material when it is supplied with heat energy that raises its temperature. It is which is when ocean water expands as it warms. In addition to this, historically, scientists began tracking ice loss using satellite imagery in the 1970s. Since then, we've seen consistent patterns of ice retreat, especially in the Arctic, which is warming nearly 4 times faster than the global average. A few areas that we are going to focus on are going to be areas of concern when it comes to polar ice melt. First, we have to understand the various differences between Arctic and Antarctic melting dynamics. Then, we will circle over to the distinction between sea ice, which floats and doesn't raise sea level when it melts, versus land-based ice, which does. Rising sea levels are already being recorded both globally and regionally. and we're seeing significant impacts of ecosystems and human populations, especially in coastal cities. These major points will form the foundation for the rest of the presentation. With the few research findings that I was able to come up with, let's take a look at some of the major findings from this research. The Greenland ice sheet has lost about 3.8 trillion tons of ice since the year of 1992. While on the other hand, Antarctica is currently losing 150 billion tons of ice every year. These losses contribute directly to global sea level rise, which has already gone up by more than an inch in just the past 20 years due to land ice melting. NASA and the IPCC provided detailed satellite and climate data that clearly document these trends. As you'll see in the upcoming visuals, the numbers are not only concerning, but they're accelerating at an alarming rate. Along with that, adding to this, GRACE satellite data from NASA shows exactly where and how ice is disappearing. Sea level data from CSIRO and other scientific organizations highlight a clear upward trend that correlates with global temperature increases. These findings support the growing consciousness among scientists. Polar ice melt is both real and rapidly intensifying. The data that was collected not only confirms the changes we're observing, but helps us model what we can potentially expect in the future. Along with this is our discussion. When we look at these findings from a broader perspective, the connections to oceanography and meteorology become even clearer. As ice melts, it affects ocean salinity and current patterns, which in turn can influence climate systems around the globe. Warmer oceans are also linked to stronger storms and extreme weather, such as tsunamis and even hurricanes. There are still uncertainties in some of the models, especially regarding the stability of parts of West Antarctica, but the general trend is undeniable. What's fascinating is how local changes in the cryosphere can create ripple effects across the entire planet. Along with this, we also need to consider how these scientific findings apply in the real world. There are tons of places and cities like Miami, New York, and Jakarta are already experiencing more frequent flooding due to the rising seas. Some of these communities in the Arctic are watching their traditional ways of life disappear as sea ice vanishes. While some argue about the exact rate of melting or how fast sea levels will rise, the impacts are already being felt, and they will only intensify unless global action is taken. Along with the loss of the Arctic habitats, these are potentially affecting the polar bears from becoming extinct. All in all, in conclusion, melting polar ice is a major contributor to rising sea levels, and it represents a serious challenge for not only science, but society as well. The evidence is clear, and the effects reach far beyond the polar regions. Understanding this issue helps us better prepare for the future, both through scientific research and policy decisions that may change along the way. As we move forward, it's important to ask, how might global policies respond to rising sea levels? And how can we reverse or lighten the effects of ice loss for the future? And lastly, here are the references I used for this presentation. All sources are listed in APA style and also include data from NASA.